Energy. Whether it's electricity, natural gas, gasoline, or compressed air, it's all around us. At home, school, work, and it goes without saying we use lots of it every day. And in the midst of all of our activity, trying to get things done each and every day, we naturally tend to take electricity and other sources of energy very much for granted. The same electricity we use at work pulsates through those same power lines and into our homes. And there, electricity powers a mind-boggling array of appliances that makes us the envy of the civilized world. At home, most of us make a conscious effort to reduce our utility bills by simply shutting lights off in unoccupied rooms and by dialing down the thermostat, or at least programming it to turn itself down. But we don't turn lights or other energy-using equipment off at work like we do at home. Why? Well, we know why. The reasons are pretty obvious to those of us who work in a factory. For one thing, in the home we can easily see if no one's in the room and the lights can be turned off. You see someone in the room, you leave the lights on. If no one's there, you turn them off. It's not as easy in the shop. The rooms there, if you want to call them that, are measured in thousands, if not tens of thousands of square feet. The lit areas wrap around corners and up and down aisles. People are coming and going all of the time. Job assignments keep changing. There's just too much going on. And even a well-meaning person making a judgment call to shut lights off in an area he thinks is not being used runs the risk of making someone very upset. Something needed to be done. The fate of thousands of megawatts was hanging in the balance. Who will save them? How can they be saved? Okay, our answer to the energy conservation problem isn't as heroic as in the movies. It was actually pretty obvious that we needed to create some kind of coordinated procedure for shutting stuff down when it wasn't being used without leaving anyone in the dark. It's called the energy conservation placarding process, and as the name implies, it makes use of plastic laminated placards to provide a roadmap of sorts to show you where all the lighting and equipment shutdowns are and when they can and should be shut down. Personnel from production, trades, and management will jointly establish the most simple and effective shutdown plan for their department, and that plan will be printed on a placard. There are two parts to the placard, a map of the work area and a description of each numbered stop along the shutdown route. At the top of the placard, you can see a map showing the area affected with the switches or breaker box locations numbered in the order they can most conveniently be visited one at a time. The descriptions of the shutoff locations and what they shut off are listed below the map. To further assist you, along the map route, each energy source shutdown location will be clearly tagged for easy identification. And since some of our equipment needs to be powered back up in a specific order or at different times of the day to, for example, allow time to warm up, in these situations you'll see a separate green startup placard hanging next to the red shutdown placard. At GM plants that have participated in our pilot program, the cost savings numbers proves it works. It's an incredibly easy cost-cutting opportunity that we can all take advantage of, but obviously having a procedure in place isn't enough. It only works if we make a conscious effort, as we do at home, to put it into practice. Thank you for taking time to watch this overview of the General Motors Energy Conservation Placarding process.